Good afternoon to all of you. Myself, Dr. Nabamita Goswami, Assistant Professor, Department of Electrical Engineering, NIT Agartala, Tripura, India. Today I am here to present my paper entitled Highly Sensitive Energy Detection of Early Detection of Breast Cancer Using Surface Plasmon Resonance-Based Fiber Optic Biosensor by Shining Gaussian Beam, a wave theory-based approach. My co-authors are Vijaya Shaha and Dr. Odindu Shaha. We are from the same institute. Now, few words about our state, Tripura, the land of permanent spring. Our college, National Institute of Technology, Agartala, is situated at the capital of Tripura, which is one of the northeast states of India. Agartala is the capital of Tripura. Tripura is bounded on the north, west, south, southeast by Bangladesh. Whereas in the east, it is having common boundary with Assam and Mizoram, which are the two states of India. Bengali and Kakbara are the official languages of this state, but the medium of instruction in schools are either in Bengali or English. In the abstract of this paper, we have written that with the experimental validation, experimental validation, a new approach towards the wave theory-based fiber optic biosensor using Gaussian beam for early detection of breast cancer is explored in multi-layer fiber structure. The proposed biosensor intends to improve in the existing fiber optic based sensor in terms of sensitivity and resolution for early detection of breast cancer using HER2 biomarker. The proposed idea will result in a better sensing platform for identifying breast cancer by optically assessing the earlier stage of the cancer. In the contents, we have written that a study related to the breast cancer, then limitation of the conventional methods, fiber optic cancer detection, surface plasmon, our proposed configuration, related equation, results, comparative statements, last but not the least, references. Now, a study related to breast cancer is in 2015, about 40,000 deaths were reported in US due to breast cancer. In 2019, 41,760 deaths were reported in US due to breast cancer. And in 2020, it increased to 42,690, whereas estimated was 2,79,100. Now, in 2021, the estimated new cases for breast cancer will be 2,81,550, whereas estimated breast cancer deaths will be 44,130. The increasing rate of this issue urgently demands the testing equipments to detect the cancer cell as early as possible. Now, a comparative study between the normal breast cell and the breast cancerous cell. Healthy breast cell tissues contain 20 to 30% of water, where the cancerous cell having around 80% of water. Normal cells are either charged neutral or slightly positive. Cancerous cells are negatively charged. Normal cell produces carbon dioxide and water. Cancerous cells secrete large quantity of lactic acid. The concentration of HER2 in the blood is in between 2 to 15 nanogram per ml for healthy person, whereas it is 15 to 75 nanogram per ml for breast cancer patients. Now, the diagnosis process for diagnosis of breast cancer are the mammography, magnetic resonance imaging, ultrasonography, positron emission tomography, breast microwave imaging, biopsy, etc. are used to diagnose the early stages of cancer. Biomarker-based strategies are radioimmunology, immunohistochemistry, ELISA method, fluoroimmunology, etc. Now, the limitation of these conventional methods are expensive, monotonous, requiring arranged people, and complex labeling strategies. Now, proceed to the advantages of the fiber optic cancer cell detection. To detect cancer-specific proteins in a rapid and level-free manner, minimal size, simple, and mixed diversity of use, resulting in early diagnosis of cancer, shows exceptional ability in practical structure. Now, fiber optic cancer cell detection can be analyzed using Gaussian beam also, whereas Gaussian beam is electromagnetic radiation whose transverse magnetic and electric amplitude profile are given by the Gaussian function. Now, sensitivity of breast cancer detection can further be increased using the surface plasmon resonance phenomena. Now, what is surface plasmon? When light incident actually in the particular angle in the metal dielectric interface, then electric field associated with the incident light picks up in the metal dielectric interface. This is known as surface plasmon. Surface plasmon can be created by shooting electron into the metal or by excitation of photons. Example of excitation of photons are Otto and plasmon configuration. In 1902, who discovered this phenomena? In 1962, Lord Rayleigh gave the physical interpretation of this phenomena. In 1968, experimental setup related to surface plasmon is given by Plasmon and Otto. In 1968 onwards, we can find the product of surface plasmon in the market. Now, this is the Plasmon and Otto configuration. Here, metal is deposited after the prism in Plasmon configuration, and Otto configuration dielectric is deposited after the prism. If light incident at a particular angle in the prism metal interface, then surface plasmon will be created in the metal dielectric interface shown by the arrow line. After creating surface plasmon, light is reflected from the configuration. Now, in Otto configuration, same procedure will be followed where a dielectric is deposited directly after the prism. Sorry to interrupt. My cursor is visible to you. Are you there? Whether my cursor is visible to you, so I can give the proper presentation.
Yes, it is fine.
Yes, okay, fine, thank you. Now proceed to the physics of surface plasmon. If we proceed to the physics of surface plasmon, then we can find in the earth crust or in the periodic table of chemical engineering, we can find having three metal, copper, silver, and gold, which having one electron in their outermost orbit and full 18 electron in their formermost orbit. Now, if we somehow excite this one electron, then the one electron comes out. Then the full 18 electrons are not further stable, and they also comes out. Then we can find huge amount of electron in the surface. IP is the ionization potential to make free one electron from their orbit. This is 7.72 electron volt for copper, 7.57 electron volt for silver, 9.22 electron volt for gold. We can find huge amount of use of silver in the field of surface plasmon. Aluminium also used in the field of surface plasmon due to its extraordinary properties. Now proceed to the surface plasmon resonance. Surface plasmon resonance is the highest point of surface plasmon, whereas at resonance condition, reflectance is minimum or zero. This is the reflectance versus incident angle graph. Now proceed to the one of the side effect of surface plasmon is known as electric field enhancement effect, where the relation prevail intensity versus electric field square. Here the metal and dielectric interfaces are there. Due to the creation of plasma, positive and negative ions are separated. This is the dielectric metal interface. Now proceed to our proposed configuration entitled surface plasmon based fiber optic breast cancer detection by shining Gaussian beam. These are the specification of the components which we have used in the configuration. Here light will incident to the SMF having core radius of 4.1 micrometer, then proceeded to the multimode fiber having core radius of 7.5 micrometer to the second SMF and proceeded to the ultimate power meter head. Here the core of the fiber is coated with several layers. The growing process of the several layers are here. The cladding of the fiber is taken out by using a mechanical stripper, and then it is dipped into piranha solution for 30 minutes. After that, the gold layer has been deposited in the uncladded portion. Then the biosensing segment has been deposited into a 5% ethanol solution of APTES for 10 minutes. Now, APTES is 3-aminopropyl triethoxysilane. Now proceed to that, trailed by washing in brutaldehyde fluid solution for 30 minutes. After that, the sensor part has been submerged into a 5% HER2 antibody solution, whereas HER2 is human epidermal growth factor receptor 2 antibody preceded by antigen. Now, after that, sensor part has been submerged into 5% HER2 antibody solution. Next, for 10 minutes, the fiber with biorecognized layer has been dipped into bovine serum solution. And finally, the functionalized sensor probe has been immersed into HER2 antigen. Now, here all the analysis is done using the wave theory-based approach. Now, attractive features of wave theory-based approach are to analyze the higher order modes within the fiber. Wave theory is more convenient and effective rather than the ray theory. The similarity between the analytical solutions and experimental solutions can only be achieved using the wave theory-based approach. More accurate analysis of the cell imaging effect within the MMF can also be materialized using this approach. Now, these are the related equation. This is the Selmayr equation for the core. This is the Selmayr equation for APDS. This is power coupling coefficient for each radial mode. This is coupling coefficient for Gaussian beam for 2 layer. J0, J1, K0, K1, I0 are the Bessel function of first kind, Bessel function of first kind of order 1, modified Bessel function of second kind of order 0, and so on. Now, this is our developed equation for the proposed configuration. Here, this is for the coupling efficiency for Gaussian beam, and this is the transmission loss for the multi-layer structure for Gaussian beam. This is the multi-layer structure coupling efficiency. Now, proceed to the several results. Propagation of electric field inside the MMF using input Gaussian beam. Yeah, this is the distribution of electric field with 2 annular rings for Gaussian beam at 1.2 centimeter. Here, in the configuration, propagation length of the fiber is 1.2 centimeter. Now, proceeds to this intensity distribution of electric field within MMF with propagation distance of 1.2 centimeter. This is the intensity distribution. Now, propagation of electric field along the length of 1.2 centimeter of MMF using numerical mode solution is here, where numerical mode solution is a universally accepted software through which we need to check whether the light has been properly propagated with the proposed structure or not. This is power coupling coefficient for Gaussian beam. Here, radial mode number 2 is the most dominating mode number. This is the power coupling coefficient versus radial mode number. This is transmission loss along the propagation length of MMF at HER2 concentration of 2 nanogram per ml. This is transmission loss versus propagation length. Proceed to this graph. This is the transmission loss versus wavelength graph, where HER2 concentration is varying from 2 nanogram per ml to 100 nanogram per ml. It is well known that for the healthy person, the HER2 concentration will be 2 to 15 nanogram per ml, and for cancerous patient, it will be 15 to 75 nanogram per ml. From this graph, we have observed that with the increase in concentration of HER2 biomarker, the resonance wavelength of the sensor shift towards right. Now, if we proceed to the resonance wavelength, we can find this list. If we find out the sensitivity, we can realize that the sensitivity for the 2 to 15 nanogram is more. It means that the detector will properly work for early detection of the cancer. Comparison of the wave theory-based proposed fiber optic sensor using surface plasmon resonance with the reported sensor till date, which are based on ray theory. These are the two reported articles which are based on ray theory to detect the cancerous cell. Now, this is our proposed structure. Here, the sensitivity has been analyzed using nanometer, nanogram per ml, dB per nanometer, dB per RIU, nanometer per RIU scale. Here, resolution for the proposed structure is 1.48 into 10 to the power minus 6. Analysis of sensitivity of the proposed structure with respect to the change in pore radius of the fiber is observed here, whereas with the decreasing pore radius, the sensor sensitivity increases, which is matching with the experimental verification presented in the article by D. San UTL in the year 2020. Now, proceed to the conclusion. In the conclusion of this paper, we have written that a new approach of wave theory-based fiber optic biosensor using Gaussian beam as a source for early detection of breast cancer. The proposed sensor has a sensitivity of 6,734.93 dB per RIU and 0.26 nanometer nanogram per ml, and a resolution of 1.46 into 10 to the power minus 6, which is 3 times better than the reported ray theory-based article till date. To the best of our knowledge, the proposed idea using wave theory provides better sensitivity and resolution as compared to the other existing fiber optic biosensor till date. To reduce the complexity in fabrication process, instead of using tapered, bending, U-shape, B-shape fibers, polite structure, side polished fiber, in the proposed structure, steel fiber has been considered, which makes the idea promising and attractive for the detection of breast cancer. Now, for accurate analysis of the different modes within the fiber and for better similarity between the analytical and experimental results, using wave theory based approach, the accurate solution with appropriate design can be achieved through this idea. Now, these are the references which help me to create this. Thank you all.